Hello everyone, this session I will be discussing when two lines intersect, how to find their point of intersection. First you have to decide whether two lines intersect or not. Now if the two lines intersect, there will be a common point of intersection. Our aim is to find a common point of intersection. But if they are not, if they are parallel, then how to identify whether they are parallel or not, that we have learned in the previous session. The direction ratios or cosines will be proportional, then you can say that two lines are parallel to each other. Now if they intersect, they will have a point of intersection. That point of intersection, if we want to find, we have to follow a specific algorithm. I'll tell you how to find quickly the point of intersection of two lines. Now, imagine these two lines in 3D are intersecting. This is line 1 and line 2. First line is given in scalar form, that is, say x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. These a1, b1, c1 are called direction ratios, and here x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. And whether these three quantities a1, b1, c1 are direction ratios or direction cosines, how to decide it, that I have explained in the previous session. Now to find their point of intersection, suppose A is the point of intersection. Now this point of intersection is common to first line as well as on the second line. So how do you get this? You take an arbitrary point on the first line. How to choose an arbitrary point on the first line? To take an arbitrary point on L1, the first line. We just write x minus x1 by a1, y minus y1 by b1, c1 is equal to t. T is a scalar. So now if we multiply that x minus x1 going to be a1t, y minus y1 going to be b1t, and c1 into t. So x will be x1 plus a1t, y will be y1 plus b1t. Okay, so this is going to be an arbitrary point on the first line. Let the point be now a point on the first line can be taken as x1 plus a1t. We want to write in the form of ordered triplet. This is y1 plus b1t, z1 plus c1t. Similarly, we have to take a point on the second line. So if we compare with, you just write this is equal to s. So a point on the second line can be taken as the same manner x2 plus a2s, y2 plus b2s, and Z2 plus C2S. We have taken that the point A is the point of intersection. This point A is the point of intersection. Now, if you are saying this point is A and this point is also A, then they must be comparable. So, to find the point of intersection, what to do here? We imagine that a point on the first line is of this form, point on the second line is of this form. If they intersect, now if they intersect, then A is common point. That is A x1 plus a1t, y1 plus b1t, z1 plus c1t must be equal to the same point x2 plus a2s, then y2 plus b2s and z2 plus c2s. They are comparable. So this thing will be equal to this thing. We have two equations now, that x1 plus a1t, this is number 1. Compare the second component, that y1 plus b1t will be y2 plus b2s, and then alright. So, if you compare these two, how many unknowns are there? Listen, in this equation, x1, a1, z1 known, a1, b1, c1 known. Here also, x2, y2, z2, a2, b2, c2 are known. So, you need to get the value of either t or s, x1, a1, x2, a2, y1, b1, y2, b2, z1, c1, z2, c2 are all known. If you can find the value of t or s, then the point of intersection is found. Now, your step will be, after taking the point, this may be our first step. Step 1, we have taken the point as A. Step 2, we have compared. And step 3 going to be what? You compare any two of these equations for t and s, and then check whether the third one is satisfied or not. So your first step is what? To find the point of intersection between two lines. Step 1, we take arbitrary points on two lines in terms of two parameters. What we have taken? Two parameters means that is t and s. First one for t and second one for s. Step 2, compare t and s by using equation 1, 2 and 3 stated above. Step 3, solve any two of three equalities 1, 2 and 3. Then what will happen? Because t and s are known, t and s are unknown, so you will get t and s just by solving from two equations will be enough. Solve any two of 1, 2 and 3 for t and s. Now what to do? Check whether the third equation, this equality, third equation, if you have solved these two, then third one going to be number 3 here. Check whether the third equation is satisfied for T and S, which you haven't used for finding T and S. You have to check whether the equation is satisfied, the third one say, satisfied by those values of T and S which you have got in 1 and 2. Then step 5. That point of intersection you get by putting T or S. Putting T or S, we get the point of intersection. Going to show you one example here on it. Now the question is, if the third equation not satisfied by T and S, then what will happen? That also you need to check. When you are checking this, imagine that the third equation not satisfied by those values of T and S you got by solving any two equations. Then what to say? Then the third equation will not be satisfied. We draw the conclusion that the lines do not intersect. Okay, I am taking this example here. So that these two lines do not intersect. How to answer this question? If they do not intersect, then how to answer it? So we first take a point on this line. You start this final, let x minus 1 by 3, y plus 1 by 2, z minus 1 by 5 equal to t. So x is 3t plus 1, y is 2t minus 1, and z is 5t plus 1. You got a point on the first line. Then what? Then you compare the second line with S, another parameter. So let exactly the way I told you, I will be using that method. This is equal to S. Okay. So a point on the second line, a point on the first line is what? A point on the first line is of this form, 3t plus 1. Okay. And how to write a point on this second line? Similar manner, a point on the second line, how will you get? Just compare. X is going to be 4s minus 2. Cross multiply here. And next one, 3s. Hope you have understood. So you got a point on the first line, you got a point on the second line. If they intersect, if lines intersect, two t minus 1 is 3s plus 1. Okay, we have just compared x coordinate of first one with x coordinate of second one, y coordinate here, y coordinate here, and this is the z coordinate. So what is according to the steps that you have to find, you have to solve any two of the three equations. Now you got equations are of what form? Equations are in terms of t and s. Solve them algebraically like x and y. Solve these two. So this is 3t minus 4s, number 1, and this is 2t minus 3s minus 2 equal to 0. Okay. Now to get the values of T and S, we just multiply first one by 2 and second one by 3 and then subtract. Any method. This is 6T minus 8S and this one 6T 9S these two are getting cancelled. So S is going to be what? S is minus 12. Clear? So put this value of S in 1. Putting this value of S in 1. For S minus 12, from 1 we get 51. 3 equal to 51. So T will be 17. We got the value of both S and T. Now check whether the third one satisfied with this value of T and S or not. If satisfied, then they intersect. If they don't, then we will say that they don't intersect. Put it here that 5T in this equation, LHS is what? 5T plus 1. 5T plus 1 you got, RHS is what? 3S minus 1, 3 into 17 minus 1. Alright? So here you got 50 and there you got 86. Do you think they intersect? No. If they intersect, that Z coordinate will have the same value. Here, once you are getting Z coordinate 86, then you are getting 50. It is not possible. So, what will be your conclusion? Since the third equation not satisfied, so third equation means this one. As the third equation not satisfied, as number 3 not satisfied by what? T and S. So this will imply that lines, the given lines do not intersect. Am I clear? Very simple. You just take a parameter on first, or better to take a point on the first line, point on the second line, the way I told you. If they intersect, they have same x coordinate, same y coordinate, same z coordinate, because point. So we have compared, we have solved for T and S from any two, and then we are putting in the third to get alpha, to check whether LHS equal to RHS or not. They have not satisfied the relation 3, so they do not intersect. Is it clear? What to do in vector form? Point of intersection to find the point of intersection between two lines if lines are given in vector form. So vector form means the first one you can write R equal to A1 you can take this from R equal to A plus TB or A1 plus TB1. A point is A1 and directed along B1. Second line R equal to A2 plus TB2. Concept remains the same. If they intersect, they have a point of intersection. So I will take a point on the first line. This is going to be A1 plus TB1 only. A2 plus TB2, I simplify the result. You take the two equations, both the equations in this form. R means xi, yj, zk. A1 means x1i, y1j, z1k plus t into, we will be taking b1 vector in this vector, say this is you take it this manner, a1i b1j plus c1k. This is your first line, and second line if you write A2 point we are taking in the form x2, y2, z2. Plus s into a2i, b2j plus c2k. Okay? All those a1, b1, a2, b2 that I have written. Now, how to take a point on the first line? This is your first line. A point, number one we have rewritten here. A point on the first line x, y, z is going to be x1 plus ta1, y1 plus tb1, z1 plus tc1. Okay? So a point on the first line we have taken in terms of parameter t, because a1, b1, c1 and x1 and z1 are known. A point on the second line, that we can again get by comparison, x, y, z is equal to x2 plus sa2, similar to the scalar form. Okay, sa2, and next one is y2 sb2, and next one is z2 plus sc2. Now again you go by the same method. If they intersect, if given lines intersect, then what will happen? x1 ta1 equal to, I am doing just vector form and comparing, y1 plus tb1, y2 plus tb2. Okay, and the third one is z1 plus tc1 equal to z2 plus sc2. So you got three equations. Go with the previous sum method again. You just solve any two of the given three of the three equations you got. Solve these two. You find s and t from here. Find t and s. Those t and s you substitute in the third. If LH is equal to RHS, then the lines going to intersect. Okay? You need to check whether these two lines intersect or not. They are given in vector form. The method I have already explained. How to find their point of intersection if they intersect. That also you have to do always. So a point on the first line, we can take this form, that is i's coefficient, that is 1 plus 2t, and this is minus 1, no j is there, comma 1 plus t. T is the scalar, and a point on the second line will be what? If you take a point on the second line, it is going to be 2 plus 2s, again minus 1, and minus 1 plus 3sk. Did you understand? We have taken a point on the first line, we have taken a point on the second line. Now what to do? They are comparable. If they intersect, they must be compared. We are going to compare these two lines. As they intersect, therefore 1 plus 2t, this x coordinate will be equal to 2 plus 2s, minus 1 always equal to minus 1, and 1 plus t equal to minus 1 plus 3s. Okay? So this is going to be 2t minus 2s equal to 1. Here nothing to compare, and here t minus 3s equal to minus 2. Let us solve. You just multiply 2 by 2 and then subtract. Then 2 to 2 getting cancelled. Minus 2s plus 6s equal to 1 plus 4, 5. So 4s equal to 5. S going to be 5 by 4. Okay? Now put this value of S in the third condition here. I mean number 2 we have taken. So 1 plus t will be minus 1 plus 15 by 4. T equal to minus 2 plus 15 by 4. So t is going to be 7 by 4. Do I need to check the third equation? No, because 2 equations, 2 unknowns, and we got feasible solution over there. I mean solution over there for t and s. It exists. So these two equations, these two lines must intersect. The y coordinate is going to be minus 1 only. And how to get the point of intersection? The required point of intersection of two lines we can get either by putting t here, that is 7 by 4, or s here, which is 5 by 4. So we put it there to get the point of intersection. Here, required, either you put t or s, required point of intersection is going to be what? 1 plus 2t. 1 plus 2t, t we got earlier, that t is 7 by 4. So 1 plus 7 by 2 minus 1 and 1 plus 7 by 4. Okay? So this is going to be 9 by 2 minus 1, 11 by 4. Whenever sum given here, we check whether they intersect or not. You are just checking for s and t, this is not done. You must go till the last step so that there is a point of intersection. So the point of intersection we got here, and we can state that the two lines will be intersecting, they intersect at this point. Okay? So we have just seen that if two lines intersect, how to find their point of intersection? By taking common point and then by comparison. Now let us solve a problem where we have to decide whether, so that the lines through this and this intersect, the line through this and this find their point of intersection. This point is 394 and Q is 44. If they don't intersect, then this point will not exist. R is and S is 4, 5, 1. So in this kind of sum, you need to write the equation of lines, then go for comparison. Line through P and Q. Line through P and Q is given by x minus x1, y minus y1, this divided by x2 minus x1, minus 4 minus 3, minus 7, 4 minus 9 minus 5, and this is 0. Okay. Similarly, we write line through R and S. So this will be x minus 0 by 4 minus 0, that is 4. Y plus 1 by 5 plus 1, that is 6. Z plus 1 by 2. This is line 1 and this is line 2. Now, if they intersect, we will follow the same method. To find the point of intersection between those lines, let L be the point of intersection, we follow the same method. We compare this with T and this with S. Then L will be the common point. So point we get here, 3 minus 70, y equal to 9 minus 5t and z4. From here, a point on the second line is 4s, 6s minus 1, 2s minus 1. So we are going to get 3 equations because the values of x here and x here, y here, z here comparable. So if we compare for the point, common point of intersection, what do you get? 4s equal to 3 minus st. So 4s plus 70 equal to 3, number 1. 6s minus 1, 9 minus 5t. So this will give us 6s plus 5t equal to 10. This is yes. 6s plus 5t equal to 10. And the third condition, that 2s minus 1 will be equal to 4. So we get the value of s directly from here, from number 3, and then we will check these values of s. You need to get both s and t. So you take s from here, 2s 5, so s going to be 5 by 2. Now if we put s equal to 5 by 2 in number 2, by putting s equal to 5 by 2, 5t 10 minus 6s, 6 into 5 by 2. So 5t equal to 3. This is minus 5, so t is minus 1. We got s 5 by 2, t minus 1. Are they satisfying this equation? We have to check that. If satisfied, then there is a point of intersection. You remember the method, no? We will be solving any two of the 3 equations, find s and t, and check whether third one satisfied. So we have solved 1 and 3, we will check number 2 only. Putting is 5 by 2 and t equal to minus 1 in 2. The left hand side of 2 becomes 6 into 5 by 2, 5 into minus 1. 2 3s are, this is 15, 10, this is RHS. So what will be your conclusion? That value of S and T satisfying. So S going to be 5 by 2 and T minus 1. Go back there. S 5 by 2 and T minus 1. You got point of intersection here, same point is there also. So either you put S or T. That point, if you put it here, say this is our number 3 and this is number 4. From 4, if we put the values of T over there, X is coming to be 3 minus 7 into minus 1. This is 10. Y 9 minus 5 into minus 1, that is 14. And Z is equal to 4. Hope you have understood. Okay. So the point of intersection, in this case, these two lines intersect at L. That point is given by 10, 14 and 4. Clear? Taking another problem here, find whether the lines intersect or not. If they intersect, find the position vector of their point of intersection. R equal to 2i 3j plus k plus t into and R equal to that 6i minus k is into I minus 3j plus k. So in vector method also we need to take a point here, but advantage here, this is more precise than that in scalar form. There is no I over there. So it is 2i and j 3 plus 5t into j and k is also there. I mean that coefficient of k is 1. Okay. And for this one, 6 plus is I cap, three is j cap, s minus 1 k cap. Alright, 6 plus is I cap minus 3 is j cap, s minus 1 k cap. So if the lines are going to intersect here, then this point is common. So a point on the first line whose position vector given by this must be equal to point on the second line whose position vector given by this. This is line 1 and line 2. They have the same point of intersection. So if they intersect, then the position vector of their point of intersection is common. Okay, that is in the first line we will assume that this way, second line will be same here. So therefore 2i 3 plus 5tj 1 minus 4t will be equal to 6 plus SI 3SJ plus S minus 1K. So comparing, we get 6 plus S equal to 2 minus 3S equal to 3 plus 5T, and S minus 1 is 1 minus 4T. From here we get S equal to 6 minus 2, that is 4. Put it here. Minus 12 equal to 3 plus 5T. So 5T is minus 15. T going to be minus 3. Now with these values of S equal to 4 and T minus 3, we need to check this one satisfied or not. Here if you put S equal to 4, LHS becomes 4 minus 1, 3. And for this is for S equal to 4, the LHS. RHS is what? RH is 1 minus 40, 1 plus 12, 13. 3 is not equal to 13, so they never intersect. Therefore, they do not intersect. Hope you have understood the concept how two lines intersect, how to get their point of intersection. If they don't intersect, obviously they don't have any common point of intersection. Okay, thank you. See you again in the next session.